will have the presentations. Okay. So as I recall, can you tell me what was the last slide we had in the previous session? I think we discussed this slide, and this one is the last one I remember, as I think. Okay, can you tell me, so which one is the last slide? This slide or this one? You mean this? Okay. Okay. Let me check. One student sends a message. Thank you. Thank you. So let's continue. Guys, I told you about NFS or the network file system, which has been introduced by Sun Microsystems, or currently Oracle systems. And then we proceed to some necessary terms and other introductory things. But now I'm going to tell you about the network file system with more details. I'm going to discuss some other aspects of this successful technology and its influences on other technologies, other frameworks as well. So let's see this slide here. Okay. Guys, we have NFS version 3 and NFS version 4. Why am I discussing these two versions? Because beside we should know about NFS, I want to use NFS 3 and NFS 4 and the comparison between these two to teach you about performance improvement, the parallelism and concurrency and things like this. Okay, so currently we are learning NFS, plus we learn some things about how we are going to improve the performance of parallel and distributed systems. Yes, thank you, dear Mohammed Salih. Okay, as you can see here, we have NFS 3. NFS 3 will send a function, will send a command from client to server, and it will wait until it receive the response of the server regarding that command. For example, as you can see here, the client issued a lookup command. For lookup means it's a question like this: do you have that file? Do you have a.mp3? I want it. Do you have it? This is the lookup question. So client sends lookup command to the server. Server will execute this command and returns the result to the client, which obviously is a true answer. So, do you have that file? Yes, I have. Do you have that file? Yes, I have. And then, when client is sure that the server has the file, the client will issue another command to read a portion of file. For example, it says it issues a read command. Read 30 kilobytes of a.mp3. It issues this command. The client issues this command. As you can see, it sends it to the server. The server will receive this command, will execute this command get those bytes ready, and then it sends the answer, which is the 30 kilobytes of the file, first 30 kilobytes of the file, to the client. And this is time, as you can see in the figure. Time is passed in this way. Okay, this is how network file system version 3 works. Okay, now let's be more specific about these commands. These commands are RPC calls. RPC. As I told you before, when you want to call a function on a remote computer, this is the remote computer, you can use remote procedure call, or RPC, remote procedure call, or RPC. Here the client uses RPC to issue or to call a lookup command from the server, on the server. Here it calls read command on the server. Okay, guys, do you have any problem? Because I see you're typing in the chat box. Is there anything you want to say to me? There's a problem with the voice. Yes, dear Muhammad Salim. It takes more time. So, guys, as dear Muhammad Salim told here, let me zoom in. Okay. In NFS3, we send the command. We will wait for the answer. This is the waiting time here. This is the waiting time. I highlighted with this purple line. This is our waiting time. This is our waiting time. We need to wait for the server to answer us. But in NFS4, we have another approach, which is called compound RPC. Compound RPC. You can see its name here. What is compound RPC? Compound RPC packs multiple commands, this one, and this one, and this one, and sends it in one shot. One shot. Okay? Then the server will receive this package, for example, in this package of 3 commands, and then it will execute them. Yes, a batch. You can call them batch. A batch of commands. The server receives this batch or package or compound, and it will run those commands, and then it will send the final result to the client. Obviously, in this way, you can have better response time because you don't have to wait for response in each command. Okay, this is lots better than NFS 3. We call this NFS 4. Okay, guys, this is a huge performance improvement. Okay, as you can see here, by changing some simple thing, here we can have very improved performance and less response time, better response time, higher speed communications. So this is NFS 4 and this is NFS 3, and this is how we change it. This is the plain and classic RPC, and this is the compound RPC. Okay, guys? One thing to say here, there's no transactional semantics for compound RPC. What this means is that in transactions, for example, if in database transactions, if something fails in the transaction, as you may recall, I told you before, the system will roll back to the beginning of the transaction. Everything will be rolled back, and the state of system will remain intact. But in compound RPC, we don't have such a thing. If one of these commands fails, the server rejects the remainder and sends an error to the client. Okay, there's no transactional semantics, no rollback here. We don't need either. We don't need having those transactional semantics, those overhead and things like that. Because if we have some kind of information, some kind of data that needed to treat it in a transactional way, a transactional notion, so we shouldn't use an NFS. We should use a database system. Dear Rasha Samat, you ask NFS4 adds the concept of parallel NFS. In NFS4, in this thing, as you can see here, we don't add any parallelism. Okay, we just packaged different commands together and sends them in a single compound pack. Okay, this is like, okay, you want to shop things for your house. You may send your friend. You may tell him, okay, please go and buy milk. He will go buy a milk, and after he returns to the house, you may say, okay, go get bread, and he should go out and find bread and then return to the house. And then you may say, okay, now go and get meat, and then he should go out and to the same store and buy meat and returns to the home. Okay, this is one way. Another way, you can write a shopping list, and you transfer that list. You will give that list to your friend, and he will look at that list. He sees that, okay, I need to buy 3 things: meat, milk, and bread. He goes to the supermarket and he buys all those 3 things, and he will return to home. There's no notion of parallelism here. We just package the shopping items in a list, and this will drastically reduce the amount of time which is going to be wasted in the way for going to the supermarket and returning from supermarket. Okay, there's no notion of parallelism here. But I will tell you about parallelism in the next slide. But currently, there's no parallelism in compound RPC. Okay, is it clear for you? Okay, guys, there's a homework here for you. Homework. What is ONC RPC? First, what is RPC? Second, what is ONC RPC? Guys, next week at the beginning of the class next week, I want to ask I want a student to translate this to Arabic for students who may not understand me well. Next week, at the beginning of the class, we will have a 10-minute quiz. The question in the quiz is, what is RPC and how it works? This is the question. What is RPC and how it works? What? Okay, I'm telling you the question before, but you should get ready for that. What is RPC and how it works? Okay, so next week, get ready for this quiz. We will have this, and it's mandatory. Please tell anyone in this class. I think some of students are absent today. according to the list I have. I can see some students are not at the class currently, but please, if you have any a WhatsApp group, please tell the students that they should get ready for this important quiz, because this quiz has direct point in your final exam. Okay, guys, it has direct point for your final exam. Please tell them. Thank you, dear Muhammad Salim. Thank you, dear Rasha. You, Muhammad Salim, asked, can you write the homework? Yes, I wrote it here, so you can use it. And the homework was RPC and ONC RPC. You know, the homework is completely in the same direction as your next week quiz. Okay, so if you do your homework, you will easily and quickly answer the RPC. There, please, no copy pasting in the exam. No copy pasting in the exam. Write everything according to your knowledge, and try to write in English, because your final exam is in English. Okay, try to write in English. Your final exam is in English, so you should. I know some of you have problem with English. I know some of you cannot fully understand English, but for the final exam, we need to. You need to write the answers in Persian or English. You have these two choices. No Arabic, because I cannot understand Arabic, and according to to university, you should write your answers in Persian or English. So you should try and you should practice that. I know there's some exceptions. If your professor can read Arabic, you can write Arabic, but as I can't, you cannot use this option for this class. Okay. Now, is there any question, guys? Yes, dear Vanas. Remote procedure call. Is a very it is a very common technology. We use it for over 30 years now. And now, for example, Google, Facebook, Microsoft, Apple, many companies, many huge companies are using RPC in all of their products, all of their network-enabled products. It's a very well-known technology. And also we use it, for example, currently we use Web API and things like this, and they are all based on RPC. Dear Hossein Ali, I haven't decided about this about the form of your exam, okay? But the previous terms were needed to write the answers, okay? There's no choices to select, but maybe in this term, maybe I decide to use some kind of choice system. Maybe that, I know that will help you to easily answer the questions, but I haven't decided yet, okay? So I cannot answer you right now. Guys, do you have any question about this slide? There's no question. Okay, so the first thing RPC, the first thing NFS4 brings was the brought was the compound RPC. Let's continue to another thing here. Okay, please look at this. Look at these two figures. You don't need to read the text above them. Please look at these two. Okay. Okay. Can anyone tell me what are these figures about? Can anyone tell me? Rasha Sarmad mentioned it before. Yes. Yes. Guys, please take a closer look at these two figures before I give you the information. Dear Ali Sajil, I don't understand you. I don't understand your point. Can you explain more what is your main intention? Dear Ali Sajil, I'm waiting for you. Is there anything you want to add? Because I don't understand your sentence. Okay, let me discuss it. Consider this. We have a server here. We have a server here, and the server wants to call a function called invalidate to two clients, for example. Of course, we have many clients, but in this figure we have only two clients. But we can see how a slight choice can change the game. As you can see here, in this version, in version A, server sends invalidate to the client, to client 2 or the client in the below, and it will send a reply to the server, and after that, server will send another invalidate to the client, and will wait for the reply and continues. Okay, in this way, this is a sequential calling. In this figure, in figure B, we have concurrent calling or parallel calling. Look at this. Server sends invalidate to client, invalidate function to client and the below, and it sends invalidate to the client in the upper side of the screen, almost concurrently. Server in this figure, server will not wait for the replies. Server just issue the commands, and after it sends these invalidate commands to all clients, it will wait for the answers. This is what concurrency means. Let me write it for you here. It is here. Parallel, yes. This is parallel, and this is not parallel. This is sequential. Okay. In RPC, in NFS4, we have this multi-RPC, as you can see here. So in NFS4, the caller explicitly sends an RPC request to each recipient, and it will not wait for the answer. Yes, dear Fanas, it's like all IP multicast. It's very similar to that. It's very similar to that. There are some slight differences here, but the general idea is the same. Thank you for your input. Okay, this is multi-RPC or multicasting, as the Vanas also mentioned. Okay, this is in NFS4. We have this, and it's very useful. Okay, there's something else here we should talk, and this is RPC2. RPC2 is developed during the work different researchers done on CODA file system, Andrew file system, then called CODA, and it has this multi-RPC added to the traditional RPC, and also it supports reliable RPC on unreliable UDP protocol. Guys, we have two famous different transport level protocols. One of them is TCP, and the other one is UDP. I know all of you have heard about it. Uh, TCP is reliable. Okay, TCP is reliable, but UDP is not reliable. It's so it's so it's much lighter than TCP. TCP is more heavier than UDP. It imposes different actions. For example, handshaking and lots of message should be passed between sender and receiver to ensure ensure that the communication is trusted, the communication is done reliably, the message which has been sent from client will be received at the server, and if message is lost, if any message is lost in the communication, the server the receiver will request for it. These are all controlled. Also, TCP has a congestion control, which is a very useful thing, and UDP hasn't all of this. It's so thin, it's so lightweight. We use UDP when the reliability of connection is not important for us. Okay, for example, when we are viewing a video online, a video clip online, or a movie online, normally we don't use TCP because TCP is so heavy. And when we are watching a movie, it doesn't matter if some pixels or even some frames lost during the transmission. We just want to have this experience of watching a TV or watching a movie with high quality. Okay, we don't want we don't want that the video freeze, and we want to watch them in a fluent way. So we use UDP in many of our communications. It's so light. It consumes less resources. So it's a better choice for many applications. But it's unreliable. And the thing here, and the important thing here is, in RPC2, we can have reliable RPC on unreliable UDP. So we can have reliable RPC calls on top of UDP, which is an unreliable protocol. Okay, this is a very important breakthrough for RPC2. Take your time and think about what I've said. Is there any question? Is there any question, guys? Multi-RPC works like no. You know, UDP is a transport layer protocol, and RPC is usually considered as an application layer protocol. They are in different layers, okay? They are in different layers. I told you we can use RPC on top of UDP. You ask, no, no, we cannot say, because in multi-RPC, we will wait for the reply, but we will wait for after we send all of the message. Okay, after we send all of the message, then we will wait for the reply. Okay, we will wait for the reply though. Okay, another question from Mouse. I can be written. It can be written in full. I don't get your point, dear Muhammad. Can you discuss your sentence or not? I don't get your point, dear Muhammad Salim. Can you tell me more about your point, or you don't want? Okay. So this is RPC2, and it has some differences comparing with RPC1 or traditional RPC. One of them is multicasting. The other one is the support for reliable reliable RPC call on top of UDP. It supports UDP. You know, RPC1 doesn't support UDP. It just uses TCP and nothing else. But in RPC2, you can use UDP. It's so convenient. Okay, there's an important other thing here, which is called side effect mechanism. Side effect mechanism. What do you mean by full form, dear Muhammad? What do you mean? Writing what? What do you mean by full form? I don't know what is the meaning of full form here. So, what is side effect mechanism, guys? Let me tell you this with an example. Okay. I'm sorry, dear Muhammad. I don't get your sentence. I don't get your question. Can you, I don't get that. Sorry. Um, Maybe one of the students can help you on translation. Because I don't get your point here. I'm so sorry. Okay. What is side effect, guys? Look. Currently, we are using this Done software. Okay. And if I want to send some slides for you, or you want to send me those slides, you can use, or we can use this website to transfer information. Okay, it's okay. We can use it, but guys, pay attention to this, guys. You can use email or WhatsApp to send some files to me, and those ways are way better and more convenient. Okay, so we connect to each other through this website, and then I will give you my email address, and then you will contact me on email, or I will give you my phone number, and then you will contact me through phone. Okay. So I use this website to give you my phone number. We have the exact same thing in the RPC. We can use, let me bring this slide to you. We can use RPC protocol, and then when the client connects to the server, they can switch to another protocol, like what we have here. For example, here I'm coming to this website, and then I tell you, okay, guys, let's use Skype for video translation or video chat. Then we switch to Skype. Okay, we use Done website to create the base connection, and then we switch to Skype. This is an example which we can compare it with the side effect mechanism in RPC. In side effect mechanism, we can create an RPC call to the server. Okay, and then we can agree on another protocol to switch to that protocol for the remainder of our communication. So I come to this website, I tell you guys, please switch to, for example, a Skype, and all of you will switch to Skype. I will switch to Skype. We have our video chat on the Skype, and then we can return to this website, or we can disconnect. So this is what we call side effect mechanism. Okay, please look at this slide and think about what I've told you. And then if you have any question, ask them. Okay, and you can read this slide, please, everyone. It's so important to read this slide. Yes, dear Rasha Sarman, I will return. This slide. Okay, what's your question? Another example. Okay, for example, I can call you with my phone. Okay, I can call you right now, and I can read a document for you, and you can write it on your site. Okay, I can write, for example, I read a book for you. I read a book for you, and then you can write it on the other side of telephone. Okay, you get my first premise here. Here, Vanas. Okay, but it takes so much time to transfer a book in this way, because, for example, a book with 200 or 300 pages will take several days for me to read it and for you to write it. Okay. What will you do when you want to transfer a book? You just, when I call you on telephone, you may say, okay, please send the book file to me on email, and I will have your email. You will say to me that, okay, my email address is, for example, vanas@gmail.com. Then we can communicate on email. I can send the file to you. You can answer to me, and anything else. You can send. We can send so much files on email with more conveniently. Okay, to be brief. But we use telephone. This is telephone here. We use telephone to switch to email. Okay, email is not a good option for interactive communication. So telephone is better for interactive communication. I want to talk to you. I ask some questions. You will answer to me. You may ask some questions. I will answer to you. The telephone is a very good protocol for interactive communications. We know that, but it's not a good thing for transferring data. So we can switch to another protocol. For example, here we can use email to transfer massive amounts of data with ease. Okay, this is what we call side effect mechanism. We use a base protocol to transfer the information and the basics of the basics required to switch to another protocol. This is called side effect mechanism. I used telephone line to switch to email. Also, I may use the telephone uh, in the remainder of our communication. Okay, I may send the file to you through email, and I have that book, so I can ask them on the telephone. I don't need to disconnect this. Okay, I keep this connection alive, and then I send the book on this line, and then I will use again this I will use this phone line again to, for example, ask some questions about that book. Okay, this is how side effect mechanism works. Dear Ali Sajil, I cannot understand your sentences. I ask any of the students may can help you and to tell me the better English sentences. I cannot understand what you really want here. Okay, guys, can anyone help dear Ali Sajil to ask his question? Guys, can anyone help him? Guys, can anyone help him in the translation? Can anyone help him for the translation? Okay, I think Ali Sajil can tell you his question in Arabic, and someone like you who knows English can translate it for me. Dear Ali Sajil, can you write your question in Arabic? Dear Ali, can you write your question in Arabic? I think he wrote it. Uh, Now we need some. We can use Google Translate, but I know the translation is not accurate. Anyway, I'll try it. Aha. I think all of these slides are important. There's no more important thing here. No, No, dear Ali. I thank you for translation. Thank you all for translation. There's no way to filter things or to brief things, because I teach you the brief concepts, the important concepts. Okay. We cannot make any more brief thing here. There's no more important things, because I discussed each slide, and I told you about important things in each slide, and I wait for any question, any ambiguities in the slide, in your mind about that slide. So the answer is no. We cannot say that something is more important, because if something is not important, I shouldn't teach it. I teach things that I think they are important, okay, and they are relevant. So I teach what is important, and I cannot filter that. Okay, sorry, dear Ali Sajid, there's no way I can filter things here. I can eliminate the things that are not important, because if I think something is not important, I will not teach you, and I will not waste your time on less important or non-important things. Okay. Okay, dear Ali, I don't know if you got your answer or not. Okay, guys, I know English is maybe hard for you to read, but it's the way you selected, the way you've chosen to continue your study in Arabic, in English, okay? And you need to learn at least you need to learn to be able to read technical texts. I know it's hard, but it's hard at the beginning, and as you proceed, as you try, it will get easier and easier. And I think you need, for example, 1 or 2 months to reach to a point that reading English text for computer related topics, I mean, is possible for you, and you can read them and understand them. And there's no other way. There's no shortcut. There's no thing that I can do to eliminate this burden for you. Okay. So uh, let me bring you this slide, guys. Please read this slide. I intentionally copied this text from your book because it's important to read this slide. Please read it, everyone. I give you a 1 minute, and you can. Yes, dear Mohammed Salim. After this part of the course finished, we can have the presentations. Okay. What is your question, dear Vanas? We have IDM to download files and videos. Okay. How I'll. No. IDM, Internet Download Manager, creates multiple. I don't know exactly what's your question, but the IDM creates multiple TCP connections from client to the server, multiple threads, and it tries to download each part of file in a separate thread, and in this way it accelerates the download process, and of course it will be more reliable. So if something happened to the connection, it can resume the connection and resume the download from the point that it left it. So I think the answer to your question, or to your example, is no, but yes, the general idea maybe can be compared with this, but I should say that the IDM uses the exact same protocol that you may use in regular downloads. So if you are downloading through, for example, through FTP protocol, the IDM will use it. Will use FTP. It doesn't use another protocol, but here we use another protocol. Okay, IDM uses FTP in another way. It creates different threads to leverage more, to leverage the concurrency and download more amount of information at a specific time frame. But the protocol stays the same. Okay, in this way they are. We cannot compare IDM to this in this way. It's exactly. But the parallelism, if you want to compare it with the multi-RPC and things like that, as in the viewpoint of parallelism, yes, we can say that IDM massively uses a parallelism. Another question from the air, Muhammad Salim. These processes are made through communication protocols. The RPC is a communication protocol itself, and I can say yes. The short answer to your question is yes. Otherwise, if you want more details about this answer, you can ask about it. But the short answer is yes. So, okay, guys, it's important to say to you this slide, file-oriented or Plan 9 system is eliminated. It's not important. You don't need to read it off. And also this slide 13, slide 14, slide 15. Because you know, Plan 9 is not a live project anymore, so we don't need to discuss it in this class. Okay, I think we need to stop right here. And the file sharing semantics, I want to tell you about unique semantics, session semantics, immutable files and transactions. But as dear Rasha Sama told me, we have 5 students and we don't have enough time for them to present. So we can cut the class right here and we can switch to the presentations. Dear Rasha Sama, who is going to present first? Can you tell me all of the students' names? Okay. Ali Faisal, Ghasaq Majid, and Zaid. Okay. Let's start with Ali Faisal and Safa Ibtisam. Okay. And who is first, dear Rasha? Who is first?
اوكي دكتور. عندنا ما هو انترنت الشيء او الكيان الموجود في العالم المادي وجميع البيانات ومعالجتها ثبت على البيانات.
Okay, so why she asks about presenting without slides? Is there any problem? I don't get what's happening in the class. If she has slides, why she asked